It's a modern wonder, the aeroplane. Travel the skies with the speed and grace of an eagle. It's hard for us to imagine right now, but back in the day, people were flying airplanes with just the most basic of instruments. No radar, no satellites, no GPS. Charles Lindbergh crossed the Atlantic with just this, and this. What? The method that pilots used to navigate before the invention of GPS was called dead reckoning. New pilots still need to learn it. It's a required skill for beginners. See, in the air, there aren't any roads to follow or signs to tell pilots where to go. So to get from point A to point B, pilots have to use what little information they do know to work out where they are. Generally, what they know are these three things: how fast they're going, what direction they're going, and how long they've been going. There's a really basic formula that makes it all work. It's speed equals distance divided by time. Say we take off from OKC and fly towards Tulsa. The pilot knows the average speed of his plane is, say, 180 miles per hour, and that Tulsa is 90 miles away. Plug that into the formula, and the pilot figures that we can get to Tulsa in about 30 minutes. Not so tough, right? But there is one other very important aspect to dead reckoning, and that would be figuring out exactly what direction you need to go, and making sure that you keep going in that direction. That's where these come in. This is a flight chart, basically a map. Pilots plot a path from where they are to where they want to be. The direction of that line will determine their heading. Like with most maps, it's pretty easy to figure out the cardinal directions. North is up, then east, south, and west. But a heading is more precise than that. It's a number. They take this compass with 4 points and split it up into 360 degrees. 0 is north, 90 is east, 180 is south, and 270 is west. So, our trip to Tulsa? On a calm day with no wind that would blow us off course, that would put us on a heading of about 57 degrees. In the air, the pilot just needs to go in the direction that points the compass to 57 degrees. As long as they keep the needle on that heading, they know they're going in the right direction. Now, having to adjust for wind does up the difficulty. For that, you can use wind speed and direction to calculate how far and in what direction the wind is pushing the plane, and then change your heading to adjust for it. But seriously, that's it. People have flown across oceans with just these simple tools. Hold on one second though. Let's take a closer look at this compass thing. The compass needle is magnetic. It works by lining up with the Earth's magnetic field. So no matter where you are, it will always point towards the North Pole of the Earth's magnetic field. But the Earth's magnetic North Pole isn't exactly north. For pilots, ship captains, and adventurers, knowing the difference between true north and magnetic north is important. Depending on where you are, the difference between true north and magnetic north could change. But no worries, the flight chart we looked at earlier already had that difference factored in. For inquiring minds that want to know, in Oklahoma City, the difference between true north and magnetic north is about +3 degrees. By the way, compasses are also great for finding demogorgons. Just saying.